Hello, today we're going to solve this very simple problem. Let's read it together. A man is holding a 1 kilogram block by pushing it against the wall as shown in the figure. So you have a block and he's pushing it against the wall and the block is staying there. If the coefficient of the static friction is 0.2, so static friction between the block and the surface is 0.2, calculate the force he needs to apply to prevent the box from sliding down. So we have to actually calculate this force that he's applying, or the pushing force. So how are we gonna do this problem? Well, let's draw down all the forces. Here you have a block. What's pulling it down? It's weight, which is mass times gravitational acceleration, mg. A man is pushing it into the surface. That means surface is going to apply a normal force in opposing direction, and there is a friction force. Now, so if he wants to prevent the block from sliding, friction force has to be equal to weight of the block. Moreover, force you're pushing against the surface have to be equal to the normal force, because block is not moving into the wall or out of the wall. So it's not moving in x direction and it's not moving in y direction. So forces in x direction and y directions have to be equal. So F equals to normal force and friction force equals to weight. And we know that the formula for friction force is a coefficient of friction times the normal force. And since our normal force is a F, we just substitute it here, and then we know friction force has to be equal to mg. And from here we can just solve for F simply by dividing both sides of this by mu. So F equals to mg divided by mu, and it's 1 kg times 10 meters per second square, which is gravitational acceleration, divided by 0.2. It gives us 50 newtons. So the force he must apply to hold the block in place is 50 newtons. That's the answer.